Well, guys, I can't remember if I did an intro on this on this amp or not. This is Charles's Armadillo box, and from this side, it doesn't look half bad, other than it's doing about a third the wattage it should. This is the output tuner, and they had a shaft that ran across and came out the front of the box, which looked like this. It was stuffed on that. Looked like this, and it was stuffed on this tuner. So it came out of the front of the amp, and you could adjust your output tune, which is dangerous as frig. Charles wants that to go away. So he wanted me to add a couple transistors to it. I was like, cool, no problem. I was going to slap them down right here. Then I kind of got to looking. I'm like, oh. Standard rework. This thing has apparently had a lot of pills blown up in it over the years. And this thing is working. I did test it before I took it apart. But I wanted to see how the heatsink was mounted, because I'd had to line up my jig with how I drill the holes, so I don't drill a hole through a fin. And that's when I noticed this horse shit. I'll flip this thing on its lid. This is a Skullcracker heatsink. This is heatsink stock that Prime would have used on like a 16 pillar 32. They cut it by hand because this isn't square. They couldn't even clean all the filings out of it before they mounted it. And they couldn't even mount it square on the board. Now the fucked up thing is that this thing's mounted in a cabinet. It's got 3 fans in it that blow down, so it blow down in the air, would wrap over the end of the board. This sits smoothly against the bottom of the cabinet. So how in the holy frig is this thing supposed to be able to do its job to get air to move down these fins to dissipate the heat when it's kicked off at this stupid angle? Well, it's 90 degrees to the airflow, and it's kind of kicked off at an angle. The other thing I noticed is, we're going to take a top-down look. You see those little holes that are in there? That's the row of the transistors. So there's this whole asinine heatsink that goes this whole direction, and that row of transistors sits in this little row right here. It tapers off to an angle. What a joke. So before I can uphill it, I have to unfuck it. That's all I've been doing for weeks now, is fixing fucked up door chock stuff. So I've got to dismount this heatsink, and I got to flip it and reorientate it, and then I got to figure out how we can mount it to where I'm not going to hit a fin when I go to drill, and then I've got to go and I got to change everything on here basically. He wants to turn this into a 10 pill. Okay, so it's an 8 pill now, which means we're going to add 2 more transistors. So we're going to do away with the splitter. We're going to do away with this coax, do away with this combiner network, do away with this, do away with that. Put a 2 pill here. We're going to do a standard, probably 4 port, or 5 port, pardon me. 5 port combiner over here, 5 port splitter here. We're going to do a little bit different power distribution. Probably run it right down the middle. Basically, I got to board off this amp. So I'm going to take everything off the goddamn board and put it all back together. So that's my mission for this evening. But my first and foremost mission, now that I've ripped it out of its cabinet, so I got to fix it so it's got airflow. Because remember, the air would come down, comes down from the fans. This is the back of the amp, wraps around, and it runs right into the end of the heatsink fin. So all the air was exhausting down that little side and that little side. And I got to make it so that this is right, if I can. God give me grace. Okay, we'll be back. I remember how stressful this used to be to go drill heatsink, because I was like, man, I'm going to have a bit break off of the aluminum. I'm going to be fucked. Look, I enjoy the fact that I can order pre-drilled, pre-made heatsink. It's not that I don't know how, I just don't like doing it. Alright, so we got our 3/32 holes drilled and everything. We got them countersunk. We've got them all nice and spot on the money. So, right at the very last hole, this one here that I had to put, took the 3/32 drill bit, cut the edge of the heatsink fin, shattered a bit. I remember when that used to stress me out. Oh, that would have given me migraines. Now it's like, nah, no big deal. The power of a shot hammer, another drill bit, and some little bit of potato boy farming. Hey, shut up and lay down. Well, he's been a bad dog today. Yesterday he ate his kid, the kiddie swimming pool that he gets to play in, and today he decided he would eat the garden hose in 4 spots. Lay down and be quiet. It's all you get to do all day today is just lay there and be quiet. Anywho. Okay, Charles, so your heat sink's all drilled out, and so it all makes sense. Now I gotta go clean the mess out of the heat sink fins, and then I'm gonna clean the heat sink up a little bit, because this isn't an acceptable surface for me to mount these to yet. So we'll get that fixed, and then we're gonna mount this back on that board, so mount the board back over here so it can have airflow that moves through the fins. I know, it's a friggin' novel idea, but that's our goal. These holes are my goal. Gimme who. All right, let me get this thing cleaned up. I'll be back. Okay. Oh, PBI, you jeweled it. What'd you do that for? Because it looks cool. Is it going to help it do any more watts? No, not really. Does it achieve an absolute flat surface for everything to be mounted to? Sure does. Takes all the ridges off the countersink holes. Knocks any and all other little high spots off the heatsink. Sure does that. It looks cool. What other reason do I need the nut? I can't think of one. I know it's here. The customer knows it's there. That's it. Does it need to be anything more than that? No, but hell no. The major thing is that the airflow is right. So now, instead of popping a transistor every about 5th or 10th key, he's going to get some airflow. And I cleaned all the schmoo out of the fins that was left over from when they originally cut it. Novel idea, right? Clean surface area, clean fins, facing the right way with the airflow. Might give it a prayer to last more than a key or two. Just saying. What do I know? I'm just a fat kid in Idaho. Anywho, I'll put this underneath that. I'm going to smear some heatsink compound down here to marry up at the base of those transistors. And I'm going to put a little jism over here to marry up with the 2 new pills that we're going to put in line. So next time I come back, that board's going to be on here, and we're going to be ripping parts off of that thing. All right. Okay, Charles. To give you a little bit of an update, here is your 10 pill now. And I changed some things. I added a positive rail distribution to it. I replaced all the 10 ohmers because as I was going along, let me show you this. I found several of these 10 ohmers. I don't know if this is intentional or what, but they're flat broke right off at the resistor. And I found that as I was trying to redo the solder work. The output solder strip has been soldered to so many times, where the transistors go for the pill strip, has been soldered so many times that it was coming up, so I just replaced it. And in the process of replacing it, I discovered that all of these capacitors, which should be 120 puff, at least for this style of transformer and this style of build that it was supposed to be, were, what were these? 180s. So that's the wrong value capacitor. That could probably be a reason why we were so low on watts. Also, on the input transformers, I'm missing one. Where is it? There's supposed to be 4 of them. Anyhow, somewhere around here I got it. These disc capacitors are the complete wrong value. These should be 330 puff, and these were 480. So I went ahead and changed the turns on the input transformers to match up with this particular build style for us to turn this into a 10. Had to go and rewrap all the output transformers and change all that around and turn them into single-end devices and change the input capacitance. Rewrap the transformers so they're all feeding on the same side, so we got nothing out of phase. And then you have to visualize this thing. Let's say it's sitting in the same stack here at the end. We have this wrap so it's not going to be out of phase with the rest of these. even though in single-ended device it's not necessarily proven that that's a fact. But I went ahead and built you this the 2-pill add-on section. We went ahead and we built our Pentagon shape 5-port combiners, and then the most important thing is your heatsink is now mounted, so when your fans blow down, the air can wrap around, doesn't run into the edge of the heatsink that was faced this way and have to vent down the sides. It can actually vent down through the heatsink and do its job and pick up the heat power off the heatsink. So, got the last little bit to do here. We're on the home stretch. We are on the home stretch of this. I got to lay down the capacitance, or the coax, little mini coaxes that I built up for this. And I got to put some tuning tubes in this and some tuning coils, and then we're going to drop this son of a bitch in the box. Give you all new positive rail power wire. You're going to have three different leads coming off this bus bar instead of the one that was kind of slobbered down in here, kind of halfway, sort of. We're going to change it around so it's right. Found a lot of different things in this box that weren't making any sense on a very basic level. And it was like I was talking with you on the phone. This thing's been burned up so many times that there's only 2 transistors in here that are the same pill date, but it doesn't matter. They're all roughly the same gain. I know, I've checked them. So you're in top shape. These are 2 1Ks. These are brand new. According to my beta gain checker, they have gains of 75 or higher. So I think I'm ready to put in some input coaxes. We'll get that laid down first. We'll build the entire input tune section. And then the next thing I'm going to build, and I'm going to jump over to Facebook and do this live, is we're going to do the input and the output tunes, and then we're going to drop it in the cabinet. As far as we're going to do the input and output coaxes, we're going to get our tuning circuit ready to be put into the amp. Then we're going to drop this thing in the cabinet, and we're going to go ahead and tune it. So that's where we're at. On to the next step, which is going to be bringing it the last little bit home. Okay, I'll be back. Charles, you're all done, my friend. Here she is, completed in all her glory. We ended up having, as we were tuning it, this transistor quit, which was right here. It ended up going down, and I popped a new red dot in there, and it took right off. We had to change about 80% of this box. And the biggest deal with this amplifier is that the heatsink was rotated the wrong way. I think I spent enough time covering that, so we're not going to talk about it anymore. That's it. Got the combiners in. Got the new splitter in. We replaced all the resistors in the box. And yeah, let's run around the lap here real quick. First, we're going to use a 955 and a 5-watt slug between the 955 and the Armadillo 10-pill now. And I don't even know what to call this thing, because this isn't built like an Armadillo was. This is built like, I don't know, but then I come along, now it's built my way. So Armadillo BBI, I don't know. First, we're going to start off with a 1,000-watt slug in PEP, 1,000-watt slug in average, 5-watt slug in reverse back from the Bird 10,000-watt dummy load. That's not going to change unless I state otherwise. Then we're going to jump over to the 2950. At 2950, we're going to hit the 2-pill, and we're going to gradually bring on the power, and we're going to show you how the power, the drive, increases the output power. So first, let's do the 2950. Hello, audio. Hello, audio. It's about 20-30 bird. Hello, audio. And about 90 peak. Now, Charles, one of the things that you were wondering about was how many amps it pulls. Watch this. Now, remember when this came in as an 8-pill with the funky tuner that hung out the front? With the 955 hitting it, I could get about maybe 700 watts out of it. Maybe on a good day. I know when I drove it with the 2-pill, I couldn't get it to do more than about 1100. So it was way out of whack. It just was way wrong. But we went in here and we fixed all the bugs. Hello. Hello. Hello, audio. Hello. Hello. Hello, audio. About 300 bird out of it. 400 bird, just over 1,000 watts. So now, with less than a watt of reflect coming back on the input side, let's go ahead and disconnect the 2950. We're going to shut it off, or the 955. We're going to turn on the 2950. We're going to hook up the 2950. Boop. Amps off, driver amp on. So now I've got the mic gain way down on the 2950. Hello, audio. So about 200 watts of peak drive we're going to put into this thing, and like no bird. Hello, audio. There's a lot going on with people debating back and forth about this number versus this number. This number is an average number of that number at full saturation. What I mean by that is a full driven saturation. So the fact that I got the mic gain way down, we're going to get low bird numbers. Low bird numbers. Now when I was driving it earlier with my Connex 4400, I was getting 700 bird, but that thing only puts out 125 watts of drive. I was getting 700 bird, but I was only getting like 1500 peak. This thing fully chooched out, with the mic gain all the way open on it. We're lucky if I can get 500 bird out of it. It has to do with how much modulation you put into the carrier. And really, have you guys ever wondered why if you take an amplifier and run it on peak, on AM, and then flip it over to sideband and run it on sideband, you get the same numbers on average as you do peak? Just saying. Food for thought. Okay, so 200 watts of drive. Hello. And it's gone. Needle's gone. So we're going to go up to 2x. So full deflection over here is 2,000 watts. Hello, audio. Hello, audio. I remember, Charles, when it came in here, we couldn't get it to do more than about 12 on a good day with a warm breeze going up her skirt. Hello, audio. Hello. Look at how low those average numbers are. Hello, hello, hello. Now we're going to come over here and we're going to look at this 50 watt element. There's a 50 watt slug here that's sitting between the 2-pill, the bird meter, and the amp. So here's your input reflect. This is an average. Hello, audio. Hello, 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 audio. Low, less than a watt. Hello. And let's see what happens when we flip this down to 5x. So now we're reading that middle scale and we're adding a couple zeros, right? Should come up to about the 20. Hello, audio. So same as on the previous scale. What we're going to do is we're going to reach up here and turn that mic gain up all the way. Hello, hello, hello. 2,500 with about 600 bird. You can't tell me that number's not directly attached to that number, but how much audio modulation you're putting into it. So that's it. Hello, audio. Hello, audio. It's about 230 amps. You kind of have to ignore this volt number underneath full load because RF is getting into that and it's making it read false. This thing's sitting at 14.5, running at 14.5. So 2,500 watts on 14.5 out of this Armadillo Rebuild 10-pill, which was an 8-pill, then up-pilled and reconverted to a 10-pill. That's it, Charles. You're all done, my friend. This should last you a good long time. Now all I got to do is, there's a bend in the corner of the cabinet. I'm going to bend that back out straight, make it nice and clean again. The little metal shields that are on the back of the fans, I'm going to glue those in place, make sure those never come off again, then I'll put the lid on it. It'll be on its way home to you tomorrow. Gentlemen, my name is BBI. without a shadow of a doubt, I am the biggest mud duck in Idaho. Thanks for hanging in there and watching this whole video with us. And on to the next one I go, which I do believe is going to be a Sweet 16. Yep. Anyhow, come find us on Facebook, Twitter, Snapchat, Instagram, and of course right here on YouTube. Make sure to click the subscribe button down here, down there, or over there, or right here if you're on a mobile device. And follow along. I greatly appreciate it. Gentlemen, I'll see ya. Got questions? Call the number. Armadillo BBI 10 pill. I'll see you. Bye.